Welcome everybody. I will, in this very quick session, give an overview on how we in Airties have an architecture where we try to protect the personal identifiable information in the architecture by design. So I'm not Paul Praet. This slide should have mentioned that he also likes to bike, and he had a small accident, so he's now at home, so I'm covering for him. I'm Steven. I'm part of the Airties Cloud team, where we... So what do we do in Airties? In Airties, we sell smart Wi-Fi solutions to telecom operators. And the Airties Cloud team is a rather small team based here in Antwerp and also in Istanbul, where we design, develop, operate, and maintain a big data system which takes in the Wi-Fi data, or what happens on the Wi-Fi, of tens of millions of homes. So the chance is rather big that we are monitoring a good part of your home at this moment. And we monitor that data, we analyze it, and we also improve the Wi-Fi of your home for you. So in a high-level overview, what does this mean? On the, for you, right side, we have tens of millions of access points which regularly push in metrics of what they are seeing. We process that data, and for example, if you open up your app, or if you call the help desk, or even if we can improve it without interaction, we will improve the Wi-Fi for you. So this means that on that left side of the picture, we get a lot of personal identifiable information coming in. These are MAC addresses, but also the name of your phone or your television set, etc. In the middle block, we don't really need that personal identifiable information. We just want to analyze it, process it. But if you call your help desk or open your app, you still want to know what we talk about. You want to know what, if it is your phone or your wife's phone. So what we try to do in this design is we try to keep that personal identifiable information on the outsides of the system, and insides of the system try to work without it. So examples of that information can be your IP addresses, MAC addresses, SSIDs, so names you give to your wireless network, names you give or your phone automatically gets when it boots up in your network. This is the kind of information we want to protect, and we don't really want to care about in the core of our system. So how does this architecture look like? A lot of it, what we do, is based on pseudo-anonymization. So what we do is we make sure that we generate from that personal identifiable information a hash or a token, and with a pepper or a salt, which is at least on ISP level, but we can also, for example, put it at home level. So this means that every personal identifiable information will receive a unique token of which we can identify it, which we can use to process the data, but we don't know what's behind that hash. So all these tokens we put together in what we call a privacy session, and that is a token mapping. So that means that we have a token in which we keep remembering that the first token, for example, belongs to Jimmy's iPhone, and the second token belongs to a MAC address. A privacy session is an append-only kind of data structure. It means that we never remove, when a session is started, we never remove any token mappings, but we only add. So if we look at the last version of a specific privacy session we received, we can decode, if you have the decryption key, we can decode all the data in it. So we use asymmetric encryption, so this means that the one who encrypts the data is not able to decrypt it. For that one, you need the private key. So Also for de-anonymization, instead of doing the de-anonymization, for example, inside our REST proc, inside our REST API, what we use is we use a proxy in front of our REST API, which does not know anything about the real content of the data, but it sees in the JSON response a token, and it also has some metadata to know for which privacy sessions this token could belong to. And so what we do is we download, once we receive a response which contains a token, we will download the privacy sessions, decrypt it at that proxy level, and replace the tokens with personal identifiable information. So a few practical things we also do is, like everything which is related to encryption keys, we rotate those things very often. So we try to rotate, we rotate them every few weeks, 3-4 weeks. All these peppers and private and public keys are rotated. This means that we have we don't need any revocation mechanism, because if we need to revoke it, we just rotate everything and everything is revoked. Another thing we do is, because we rotate that much, it also ends and prunes the privacy sessions, because when a key is rotated, when the peppers are rotated, you need to start a new privacy session, because the tokens from the previous session are not mapping anymore to the tokens of the new session. And this also makes sure that that append-only structure doesn't append at infinity. Where do we do this anonymization? The anonymization, or the pseudo-anonymization, we can do on 2 places. We can do them inside the access points. So we have enhanced protection. For the access points where this is not enabled or which do not support it, we can also in the cloud do it. But then, of course, our cloud will receive that personal identifiable information, but in a very isolated, separate component. The de-anonymization is a proxy which is in front of all our REST services. And what you will see there is that we can also install it on customer premises. So if we install it on customer premises and we have device-side protection enabled, it means that we, in our own system, we have more or less deniability, that we can see what the personal identifiable information is and what makes sure. And because we can deny it, everything will keep on working. I still have a small animation, or Paul made a small animation. Let's see how it works. So what we start with is we start provisioning. So on the proxy side, that's the only one who has the private key. He will generate a private key every few weeks. He will put the public key to our cloud. And we will also generate an ISP-specific pepper for it. Every time an access point authenticates to our authentication service, it will receive a bunch of configuration, and that configuration also contains the pepper of the day, or of the month, or of the week, and a public key. Also here, our authentication sessions, we try to keep them very short and rotate them frequently. It's a principle we apply on a lot of places in our system. This is also one of them. So with that public key and that pepper, the device can send us all the data pseudo-anonymized, and have the encrypted privacy session also sent with it. This privacy session we set in special privacy session storage, and all the metrics which are pseudo-anonymized we put in cloud storage, and that's the data we are going to process. If you open your app or if you call the help desk, we need to be able to de-anonymize that data. We will send a request to our REST service, but it will go through that de-anonymization proxy, which will translate that token back to personally identified information once it has the privacy session. So it will first do the REST call. That REST call will contain tokens and metadata. That metadata will explain it. It can, the possible a privacy session the data is about. So if you have a REST service which answers response on 2 access points over the last 4 weeks, it will say we know which. We ask the privacy storage give all privacy sessions which are belonging to those 4 access points into those 3 weeks. It decrypts all that data, and the user sends it back. So this is, and we can do this in tens of milliseconds. So it's not that this takes long or people will see latency. We are able to do all of this in tens of milliseconds. So I think that's everything I want to explain. Still have 5 minutes, perfect. As Airties, we work with these kind of technologies and also, oh, that's the same slide. I don't know what happened extra. We work with a lot of cool different technologies. If you're interested, as a lot of people we are hiring, pass by me or go to the website. I want to thank you, and if you have any questions, you can ask Paul the questions or ask me here inside. Anything you want to know which is unclear? Did I go too fast? Because I did it in 10 minutes. I hope it was okay. So I hope you still enjoy DevOps, and have a nice day. That's it.